Start it whenever. Alright, so this is labeled A510 in Google Classroom. We started this assignment last week on Monday, but then we had state assessments and everything. We never got back to it. So if you're trying to get this done, I'm just going to go over everything basically that we covered on Monday. You're not going to be able to see what I'm pointing at here probably, maybe you can, but this slide is in Google Classroom under A510 as well as obviously the video that I'm making now. So the most important thing is on your handout, to make things easy for you, just make sure that you put these numbers that you're going to see in the slideshow. So there's a range of numbers for spectral class O, there's a range of numbers for spectral class B, A, F, G, K, and M, and those ranges are written in on the slide in the slideshow in Google Classroom. So make sure you write those on your paper, because then it's going to make it really easy for you to complete this column on the data sheet or the data table handout, and that's the first thing you're going to do. So you're going to complete this column before you ever even start filling out this table, and all you need to complete this column is to have the ranges written down across the top of your table. So do that first. And then, just to give you an example, once you have the ranges written down, for B here, it says 10,000 to 30,000 degrees. So that's the temperature is what you're seeing up here, and that's in degrees Kelvin, which you don't need to know what Kelvin is, but it's just like saying degrees Fahrenheit. It's just a different unit for temperature. So 10,000 to 30,000 is by far the largest temperature range up here. Spectral class O, A, F, G, K, and M are much smaller than B. But 10,000 to 30,000, that means any star that has a temperature, which again, temperature is on your data table in that third column, a temperature that's between 10,000 and 30,000 is going to be in spectral class B. And so all you'll put on your paper, if it's between there, so the first star that's going to fall between there is going to be Ackermer, or however you pronounce that. It's the third star on your list. It's 20,500 degrees Kelvin. You'll just put a B for that. So you'll do that for every star, and then once that's completely filled out, then you can move on to this table or move on to the chart and fill the rest of it out. So what you're going to see over here on this side, this is 100% just for you to determine how big you're going to draw your stars on your data table or on your chart. So the way I've set this up is I put a little mark here, which again, you can see this slide. You've got access to the slideshow through Google Classroom. I put a little mark here, a little mark here, and a little mark here to section this chart off into 5 sections. So this is section 1. I would put a 1 there. Everything that I've marked on here, if I were you, I'd mark it on your paper. Section 2 is the second one, section 3, section 4, and section 5. So as you move your way up this chart, the stars are getting larger. So you're going to represent that by using a compass to draw the stars. And so I'm just going to do an example here, possibly, or you can be able to look down on this and see it. Okay. So if I'm doing a star up here at the very top, that's going to be, section 5. And so when I'm using the compass, this circle is going to be any star that's in section 1, section 2, section 3, section 4, section 5. So if I've got a star in the top here, let's just say it's here, then I'm going to, and that was terrible. You got to hold down on the plastic part so it doesn't spin. There you go. So I used the large circle because that star is being plotted in section 5. So if it's in section 5, then that means that the absolute magnitude must have been in the negatives. Like the way that I drew it here would be like negative 7.5 or something. And probably before I move on, I know this was the first thing I talked about on Monday. This chart is super weird. If my filmer and I would have made this chart together, we no doubt would have had the temperature increase as you move to the right. but Hertzberg and Russell, the guys who made this chart, decided to make the temperature decrease as you move to the right, which you can see that in the numbers. That's super weird and it's hard to get used to, but make sure you're thinking about that when you're charting your stars. And then the absolute magnitude decreases as you go up, the number decreases. Now the reason they did that is because as that number decreases, the brightness is actually increasing. So there's a reason, but when you look at the chart, it doesn't make any sense and it's kind of difficult. So just make sure you're keeping that in mind. That negative absolute magnitude, those stars are up here, and a star that has an absolute magnitude of 15 is going to be all the way down here because it's kind of backwards. I think one other thing that I definitely haven't been clear on, you're going to chart every single one of the stars in your data table. So you're going to chart all these stars over here. But this is all you have to do. Once you've determined using the temperature and the absolute magnitude where the star should be, then you're just going to do the circle based on if you're in section 5, 4, 3, 2, 1 from what I've written up there and what you'll put on your chart. And you're going to do every star. You don't have to label the stars. This is good enough. Just do the circle. There's going to be a bunch of circles that will end up overlapping, and that's fine. And last thing, when you're done charting all those stars, the third sheet in this handout has questions 1 through 6 here, and you'll just answer those questions. Some of them are going to take you back to this chart with the stars, but you can just answer those questions here or on a separate sheet of paper or on the back. It's up to you. There's probably enough space here if you wanted to do that. Cameraman, did I miss anything?